instance data uses the right codes in the value set. And on top of that, structure definitions contain FHIR path, which is an expression language we invented ourselves, so it was on us to write FHIR path evaluators as well. And then all of this combines is finally what validation does. So you can see why validation, profile validation, wasn't exactly the first feature we implemented in both of our stacks, because it required a lot of pre-existing things like value set and terminology server support, somehow access to structure definitions that are stored in servers, databases, specification zips, whatever, and then also execution of FHIR path constraints. Once you've got all that in place, you can finally do validation. So the fact that we can do validation now is actually a major milestone. I still think it's the uber part of the library that does everything. So in .NET, the .NET library is split up in 4 packages, and the validator is hidden in a package called HL7.FHIR.specification. It references all the more basic things, amongst which, of course, HL7.FHIR path, as I just said. It does still need the precompiled POCO classes, though I'm on my way even changing that, you don't need those anymore. And then, of course, it references basic support that is in that other library there. But FHIR.specification contains everything you need for validation, which is all the structure definitions for the base specification, plus terminology services, plus FHIR path, and the validator itself. It's available on .NET 4.5 and .NET 1.3 Core, so you can run this on Macs and Linux, and we're actually doing that. Those who've seen one of my talks before on this, have seen this before, but I have to reiterate it. This is the glue between everything in my .NET library. It's called Ionic Navigator. Ionic Navigator is an abstraction that represents FHIR data separate from the physical representation like JSON or XML, or POCO, because that's another representation for FHIR data. And Ionic Navigator abstracts over that, and it's a simple tree. It's a tree with values and names. So if you have patient.identifier.use, and use is, one of the uses is usual, I believe, one of the codes there, you'll have a tree with patient and a node in it with identifier, a node in it with use, and so on, and you can navigate that tree. That tree is represented in Ionic Navigator. In another talk, the .NET Advanced talk, I've gone into details about that. I won't do that here, but I just want to make you aware of this interface. This interface has 3 implementations currently. One on top of XML, one on top of JSON, and one on top of POCOs. So whatever representation you have at hand, you have an Ionic Navigator that implements navigating over that stuff. And luckily, the parser serializes the validator and the FHIR path evaluation engine. They run then over this, so you can combine at will. If you manage to implement Ionic Navigator on your own private POCO classes, you can run FHIR path on top of that, and you can run the validator on top of that, and you can run the serializer on top of that, which funnily would enable you to serialize to XML, maybe your own custom POCO model, as long as you implement Ionic Navigator. So enough about that. Then we need, second player in this whole story is the specification data. This was the instance, right? This is where the instance data comes from when the validator runs. So you read, either you have a POCO, probably in our examples I'll just use a POCO, you have instance data here, implements Ionic Navigator, and we can pass it on to the validator. This is the instance bit. Then the specification bit. The same assembly, the HL7.FHIR.specification. Whatever package on NuGet, has .NET support to read structure definitions and do things with them, but also contains all of them. In my previous session, I already said you can download those things from the specification in the site. It's a huge file with bundles with full of structure definitions, and we distribute them in this NuGet package. Specification.zip. It has everything: profiles resources, profiles types, extension definitions. These are all the definitions that come with the core specification. search parameters, all the value sets available, and so on, all packaged in specification.zip. Then, to access that, there is an interface called iResource-Resolver, and the most important thing here is there is one function there resolved by canonical URI actually, and so anything implementing this is how you get to the spec, will turn any canonical URL into the actual structure definition that you need. So this is of course what the validator will do. The validator will encounter a reference, a canonical URL pointing to some profile, and then he uses the resource resolver passed to the validator to actually get to the specification metadata. The current API supplies you with a few default implementations. One is the zip source, which accesses that specification.zip. There's directory source, which points to any directory in your application installation. So you can drop your own structure definitions and value sets there, and it will read those. And then there's the web source, which will go out to the web, which I have hardly ever used because no one really wants that. But you could point this to a registry. So if you don't have it in a zip and you don't have it locally, you head out to a registry to get it. You could do that. And then there's two that allows you to combine these things in all kinds of useful combinations. I don't have the slide for it, but you can guess that I will have a multi-resolver that first tries the zip, then the directory source, and then the web source. And definitely the web source is encapsulated in a cache resolver because you don't want to go out every single time you meet a certain external canonical. Yes?
The directory source, is there any constraint regarding, is it the name of the file, or does it load all files and read the content, or?
The directory source has all kinds of masks and things to limit the files. So you can point it to directories, fools, executables, DLLs, XML files, JSONs, whatever, and you can control which files it will actually look at. This has even gotten better in the last version, by the way. So, instance data, access to the definitions, final terminology. Yet another interface, iTerminology service. I'm not even going to look at iTerminology service, just say to you that we have 3 implementations of that interface. So the validator reaches out to a terminology service by use of the iTerminology service, and there is 3 implementations. One is local terminology service, as supplied in the specification assembly, and it does in-memory expansion and lookup of codes. It is limited. It can't do everything. It doesn't have Snowman inside or any of those things, so there's limits to what that can do. But in case that happens, there is an external terminology service which goes out to any professional, real, production strength terminology service to do the real work. And obviously then I need a 3rd implementation called fallback terminology service that first tries in memory, and if that fails, heads out to the big world outside and does terminology service access externally. So the slide I started out with combined in a single picture. The big picture has the validator here, inside it a fluent path. FHIR path compiler. So where's the instance data? The instance data is here. So either we have a raw XML file or a POCO, and we turn it into an Ionic Navigator, and this goes as instance data into the validator. The validator will be passed either by argument or something that's inside the instance data, canonical URLs to structure definitions that you want to validate this stuff against. So it goes out to iResource-Resolver to find structure definitions. One of those things might be value sets, and so it would go to the terminology service when it encounters a binding and try first the local terminology server, which might call the value set expander. All this stuff are classes in the .NET API that you can use. So you can build your own local terminology service by using the value set expander that's included in the library, and the external terminology service. And this combined will provide the terminology service to the validator. It then runs it. When it encounters FHIR path, it will use the internal FHIR path compiler, and finally it will produce a set of operation outcomes. This is our trusted operation outcome resource. So it generates a list of operation outcome resources, which you could just dump back to the client if you want. If you're a web server and you're implementing $validate, all you have to do is call the validator and return it the operation outcome. Probably you'll also have to implement iResolver on top of your database of profiles in your server, but you can do that. Some practicalities. We're getting almost down to code. We won't do the code yet, but so all this work is done by class validator in the HL7.5 validation namespace. You can configure it by new validator and passing it settings. And the settings, of course, you can change what it uses as resolver, terminology, and so on and so on. And then you can call one of those validations. One is straight on an Ionic Navigator. So somehow you already have access to an Ionic Navigator. One is directly on base, and base in .NET library is the base of any instance, be it a patient or a human name or whatever. And then validate directly on an XML reader. You will notice that I have forgotten to implement it directly on a JSON reader. I will add that. I was creating this slide and was like, really? Oh, sorry, I didn't have the overload to load JSON directly. End result is an operation outcome. Oh, here's code. Sorry, I did do it. But we're not going to run it. We do that later. So, the whole picture in code now. As I said, the most probable setup here is you create a validation source, so the iResource resolver from the zip. You probably have your own C data, my profiles directly with your own stuff, so you embed that in a multi-resolver that first tries this one. Yes, in this case, first tries this one, so and then this one, so yours override the ones that are in the standard if you really want it, and then it caches all that stuff. So here is our source of definitional information. Then I create a new validation settings, pointing. This should have been source, right? Yeah, resource resolver to source. I say generate snapshot is true. For those who were with me in my previous session, what this does is if you only supply it a differential, it will generate the snapshot for you, which is a horribly difficult operation, so you'd be glad that it's there. Actually, when I'm passing the XSD, I want you to run the XSDs if they're available as well. Trace is false, that's for debugging purposes. And resolve external references is there when your instance data refers actually to other resources. So if you're validating a patient and it refers to an organization, you can enable resolving external references. Of course, there's a callback on the validator so you can implement how it would actually get to those external references. I'm not showing that here. Then create a new validator based on these settings. Create some patient, run validate on it, and if results are not success. Remember, results here is an operation outcome, but I've added a few things on top of that, like success, and you can go on. Another way to call the validator is to pass it not only my patient, because this is boring, it will validate it either against the base core resource patient, or if this instance has a meta.dot profile, it will validate it against that. And here you can say, please validate it against this very specific structure definition. This is always work in progress. I don't think anyone can say my validator is ready. It can always be better, especially reporting errors. It's as hard as writing a compiler returning errors, I've discovered. I have not yet implemented all kinds of slicing features. The ones you basically need are there, but not all of them. And there's no loop detection. So if you have an organization pointing to an organization pointing back to the same organization, well, play with it, I think we will do later, so I'll zap this slide. As I said, the outcomes are just operation outcomes of the validator, but I added some extra stuff on top of it, success, false, and so forth, errors add, where, so you can filter the errors you have, and so on and so on. So it's, these are extension methods if you're a C# developer. That means that you don't have to change operation outcome code, but you can just add extra methods to it, and that's what I did. These are the basic ingredients from the .NET library. Any questions about that? Okay.
Just a quick one.
Lucky.
The validator was not fully implemented, and you mentioned some of the things that it couldn't, like certain references.
Yeah.
Is there any specific list? So when I'm trying to make this validation and it doesn't fail, and I'm thinking, what am I doing wrong?
What I'm doing wrong. What you do is you go to my GitHub repo for the FHIR library, and there's an issue list. And I have made sure that all the stuff that it didn't implement is there as an enhancement issue in that list. I'm looking forward to this one.
Let's talk about Java. All right. So the really fun thing about the Java library is it's basically all of, I mean, it has all of the same concepts. I mean, I guess there's only one, really, there's only so many ways you can do this stuff. So everything that Ewa just talked about, we have basically an equivalent of that does kind of the same thing in Happy. A bunch of this is a repeat for anyone who was in the advanced Java class yesterday. So if anyone was in that lecture, sorry, you're about to see it for the second time. We'll try and make it interesting anyway. So I always like to start with this. I mean, before you talk about validation, you kind of have to talk about why are you validating in the first place. Because there's a bunch of trade-offs there, of course. I mean, we've written systems that are super strict and validate everything before we save it in the database, which is good. You know for sure you've got perfect quality data, assuming the validator is doing its job, which is a big assumption, of course. But I mean, there's a lot of advantages to that. But of course, the disadvantage there is you're potentially rejecting data that is mostly good. And depending on what problem you're solving, that might or might not be a good, thing. A way that we often develop software in organizations I've worked for has been sort of to use as much validation as possible in development environments, turn everything, turn all the knobs up to 10 and be really strict about rejecting bad data in development so that you catch problems early, but then turn the knobs down in production so that you're a little bit more lenient. So, I mean, a bunch of what I'm going to talk about here sort of goes into how do you adjust those knobs, because there's lots of ways of being strict and lenient. So you kind of always have to consider that. The other big trade-off, of course, is performance, because validation, no matter what, there is always at least some performance penalty to pay, just because, I mean, especially if you're doing sort of terminology lookups and stuff like that, there will be a performance impact. So a few considerations around validation. Validation in Happy has kind of two concepts. We've got the validator itself, and then we've got this other thing called the parser error handler. Everything that Aweeb just described kind of aligns roughly with the validator side of that equation. I'm going to talk quickly about the parser error handler first. I actually don't know if this is a concept in .NET. I guess we'll find out. I assume there's probably something like this. The parser error handler is kind of this quick and dirty validator that really exists only to detect problems while the parser is doing its job. So what it's looking for is just basic structural issues with the content that you're trying to parse. The nice advantage of the parser error handler is that it has no performance penalty at all. It's super fast. It doesn't alter the speed of the parser in any way. So you can add it and not worry about it much. Really all it does, though, is catch sort of structural issues, like not FHIR problems, but problems really with the way you've encoded your data. The best examples of that, I mean, if I create a patient and I add, an element in the patient called foo, I can catch that with a parser error handler. If I have something, patient's got a property called active, which of course is 0 to 1. If I put that in a JSON array, for instance, so I make it multi-valued, the parser error handler can catch that. It catches, data type mismatches. What I mean by that is, if I'm doing a Boolean in JSON and I've passed in a string or something like that, it catches little issues like that, and it catches them sort of quickly. The parser error handler, I've got a little example of code. There's really not much to it. Where is the laser on this thing? Is that? Nope, that's it. So the parser, really all you do is you pass in this little parser error handler. Parser error handler is an interface in Happy. You can provide your own implementation, or there's two built-in implementations, and they're both super simple, actually. The first one is this thing called lenient error handler, and it's actually the default if you've done nothing. The lenient error handler, all it does is log issues if they come. It's got this little true-false in the constructor that actually just says, do you want me to even log this, or should I just silently ignore problems? What I've got there is actually the default. If you don't do that line, it will happen anyway. And the way it works, I've got an example here where I've created a patient, and I've given it this property isNice, which of course is not a real thing in FHIR. So the output that's going to come out is going to warn me. It's going to say unknown element isNice found while parsing. This, of course, this is one of those things that, I mean, this is great to make the application sort of lenient. It's kind of an issue in production systems because naturally if somebody sent you that element, I mean maybe as nice is not important, but maybe that's important clinical data that they have just put a typo in their code. If you're using this lenient error handler, of course, that just gets silently ignored. I mean, the code really has no idea that it's ignored that other than the fact it's logged it somewhere. So this is a trade-off, of course. The other way you can do it is by using the strict error handler, and the strict error handler does not log things. It will, there we go. It will throw an exception. It will throw a data format exception. So that's your other option there. So, I mean, bottom line, the way we've usually done this is to turn the strict error handler on, and generally if the system is processing important data, we will leave the strict error handler on, even in production, just because you really don't want to be ignoring any data that comes across. You don't want to be silently ignoring data, I guess is the point there. So, that is everything around the parser error handler. Let's talk about profile validation, which is more of a, yes, absolutely.
This is an interesting discussion, I think, to see how we did this both. I'm not looking at the news or anything on Facebook. I'm keeping notes here. Maybe we can discuss afterwards. Is that a good idea?
Yeah, absolutely.
Instead of interrupting you, well, now once, but
yeah, that sounds good. So, was there another question as well?
Yeah, the strict error validator stops at the first error, basically.
That is correct, yeah. So the question was, does the strict error handler stop at the first error? It absolutely does. It had never really occurred to me to have it sort of keep tally of all of the errors it finds, and then maybe throw an exception at the end of the parse. That would actually be a good idea. It doesn't work that way, but it probably should, actually. Making a mental note to go back and revisit that. Nice, thank you. Cool. So let's talk about profile validation. So I mean, of course, you know, the tiniest recap of ever on profiles. Naturally, a profile in FHIR is a collection of resources, essentially a structure definition resource or one or more of those things. Probably some value sets, probably some code systems. Take a combination of those three things, and you have got a profile. Profile validation is used to validate your resources against those things, and profile validation is where you can get into the ideas of more semantic, less structural, more semantic validation. So typically what you're doing is checking cardinalities, checking for extensions that maybe are required in your profile, checking that no values have been provided for something that's been constrained out. Oftentimes you're checking bindings to terminology, so you know, if you've got a vital signs observation profile, for instance, you're checking that the right LOIN codes have been used, that type of thing. So we're really now getting into much more sort of fine-grained validation for a specific purpose. That's kind of the idea with profile validation. Everything in Happy's validator sort of falls around this idea that we've got a thing called a validator. We've got this thing called Happy's validator. It's got this concept of modules, and what you do essentially is you create a validator instance and you'll wire it up with one or more of these modules for doing different types of validation. And I'll take you through examples of what those things are in a minute. But before we get to that, the way the validator works is it takes a couple of potential inputs. You can pass it POJOs, basically your Happy model objects, or you can pass it raw strings that are JSON or XML, and it will take one of those three things as input, and then it will return to you essentially three things. In the little wrapper object, you get a nice Boolean pass or fail. You get a list of issues that are sort of provided to you as structured Java elements, and then you get an operation outcome that you can return to people if you want. So, I mean, it's structured slightly differently from how it's done in .NET, but you're getting all of the same information back, just in a slightly different way. So, looking at the modules we've got, the first one we have is the schema and schematron module. So you can wire up a schema or a schematron module into the validator, and you can run that. What the schema and schematron modules are doing, of course, is validating against all of the schema definitions and the schematron definitions that are provided with the core FHIR specification. So if you conform to one of those things, you basically know that you haven't got any elements that are not defined in FHIR, that you're following any sort of mandatory requirements defined by FHIR. I mean, if you're dealing with an observation, the status is required, so if your status is missing, the schema will detect that. There are things called invariants, of course, in FHIR, and an invariant is essentially a rule of some sort within FHIR. The most common example is if field A is populated, field B has to have a value as well. Invariants tend to cover that type of thing, although they can be much more complicated. And the schematron definitions basically include all of these. So including one of those, including these modules, basically the schematron modules, means that all of those definitions get checked. So when you use these things, you basically, this is kind of, you basically have to include two jars, two sort of library dependencies in. And these are kind of equivalent to the concepts we saw with .NET. What you have to include is this FHIR validation resources jar for the version of FHIR you're trying to support, so in this case DSTU3. And that is basically a different way of repackaging that specification.zip that we saw for .NET. So this jar file contains all of the schema definitions, it contains all of the code system and the profile definitions, all of the value sets that are bundled as a part of FHIR. Basically all of that stuff you find in specification.zip has been repackaged into a jar file, and the only reason we do that is so that we can push it up into Maven as a normal sort of dependency that you add in your project. The one other library you add is Flock Schematron, which is just a third-party library that does Schematron in quite a fast way, so it's kind of nice. The way you do this, looking quickly in code, I'm creating an encounter here. I am asking a context. Of course, everything in Happy starts with a FHIR context for whatever version you're dealing with. I will ask it for a new validator, and then by default, actually, I mean, the one thing that's missing from this is I don't configure any modules. By default, if we don't configure any, it will take schema and schematron. They're the default modules for the validator, so I will run that, and what I'm doing here is logging out success. This is an encounter, and of course this encounter is missing status, which is required, so this should actually generate an error, and I think my next slide is an example of that, and it is. So what comes out of that is false, and naturally, I sort of highlight this only to show you that schema errors are awful. The problem, schema is nice because the schema validator runs fairly quickly actually, it's decent from that perspective. But it tends to produce really cryptic errors. This one says the content of element encounter is not complete, one of identifier and status is expected. That's actually a relatively good error from schema, because at least it tells you the name of the thing that's missing, although it doesn't tell you which of those is actually causing you a problem. Oftentimes schema will not even tell you the thing you're missing, it'll just name some other element that is expected to come before it. So schema errors are really cryptic, but it is fast at least, which is kind of nice. You can do the same thing by passing a string in, and I just sort of show that there. I think we'll get into that a little bit later with code. More importantly, let's talk about sort of doing proper profile validation. So, I mean, the concept, of course, with profile validation is up in the metadata section at the top of a resource. You have got a declaration generally of a profile you conform to. If there's no declaration, we just assume it's the sort of base profile for whatever resource you're dealing with. You know, patients, the core base profile for patient, for instance. You can have declarations up there for other profiles as well, and servers can sort of require, they basically can have rules configured within the server that any patient that comes up has to conform to a given profile. For any of those things, we basically, trying to say here. We basically, the server can be kind of configured to run all of the validation tools I'm about to talk about. So essentially when you create, the next module type, that's where I'm going. The next module type we create is this module called the FHIR instance validator. And the FHIR instance validator is the profile validation module that you pass into your validator. All of this makes more sense when you see it in code, but there you go. Much like there was a bunch of implementations of, I forgot the names of them, but there's the implementations of those interfaces we saw in .NET that go out and fetch structure definitions and run terminology services and stuff like that. All of those concepts in Java have been actually merged into one single interface, this thing called iValidation support.
This must be the first time that the Java version has less interfaces than the
Yeah, no kidding. Yeah, it's I guess an interesting difference in implementation. So Java's root is just we have this one great big interface called iValidation support. It's got a couple of key methods. There's one actually I realized as I was putting the slide together that's missing from here, and I couldn't find the source of this image to fix it, so I'll just describe it. So we've got methods for fetching structure definitions, expanding value sets, and grabbing code systems. There's one other method in here called validate code. Actually, there's two. There's one supports code system and one validate code. Yes?
So for a fetch structure definition, can you point that to a directory like you can with a .NET API? And
Yes, totally. Hold that thought for a second. The question was, can you point this at a directory like we can with .NET? And I will come back to that in just one moment. So the whole point here is we've got a whole bunch of these sort of methods you can provide, and essentially the way the validator works is it will try these things, and essentially any of these things are allowed to return null. So if I try and fetch a structure definition and there is no such structure definition, we're allowed to return back null, and depending on what the reason was the validator was looking for that, it will make an appropriate decision about that fact that we couldn't find that thing. And then we've got a bunch of implementations of these interfaces. So let's talk about those for a second. And these kind of align quite well with the concepts we just saw. First off, we've got this thing called default profile validation support. What that is doing is just using the FHIR built-in, like the FHIR core specification resources. So that's using that structures jar that I talked about a minute ago, just to take all of the built-in structure definitions and value sets and code systems and all of that stuff. We've got this thing called pre-populated validation support. Pre-populated validation support is essentially if you've got a bunch of hard-coded structure definitions, for instance, what you do, it's got actually just a simple hash map sitting inside itself, and you can sort of load up any structure definitions in there you want, keep them in memory, and they will sit around there. The next one we've got is validation support chain, and this kind of aligns with that I forget, what was this? Yeah, exactly, the multi-resolver. This aligns to multi-resolver, and it's the exact same concept. The idea there is you can pick a couple of these validation support modules, and it will try each one in order. So the idea generally there is if you've got one that's fetching from the web, and you've got one that's fetching from the base definitions, and another one that's looking at a database or a file system or something like that, depending on what you're doing, you've probably got a sequence in mind for how you want to do that, and of course you can just sort of wire those up in that sequence using the chain. There's one final one I'll mention. If you're using Happy's JPA server, like the full-blown database stack and all of that, we've also got an implementation that looks inside the database. And that's kind of, there's actually some fun when you're wiring that up there, because you kind of, one of the decisions you want to make is if we're talking about the base profiles, do we grab them from the database, or do we use the, or do we allow people to override those things, which is kind of it's an interesting challenge, actually. Now getting back to Rick's question, there's a few more of these things that sort of float around the Happy library, covering things like file systems and web resolvers and stuff like that. I personally, I mean, they've been contributed. I've never actually used the web resolver, probably much like AWeb, for anything sort of real, nor have I ever actually used the file system ones. They do exist, but I haven't found them to be terribly useful when I'm trying to solve real problems. So I don't even list them on the slide. I will mention one other thing the validator does, which is kind of useful beyond validating profiles. It will also validate questionnaire responses. Questionnaire responses, of course, need to be valid FHIR and valid against structure definitions, but they can also be valid against the questionnaire that defines the questionnaire response, or that the questionnaire response declares that it is a questionnaire for. So the other bit that we kind of do is if the validation support is able to fetch a questionnaire for a given questionnaire response, that's another method that's in there. Then it will do a bunch of questionnaire validation, checking things like if a question is required, do we have an answer for it, is it the right data type, that type of thing. Does .NET do that?
Sorry, what?
Does .NET do a questionnaire validation as well? That's an interesting one. We had that before we had profile validation.
I'm saying no, but it's not, there isn't .NET implementation, it's not .NET.
Gotcha, right. There we go. So very quickly, I mean, essentially, I'm going to skip that. We'll come back to code after the break. I think that makes sense. Yeah, so that was, I just got the 5-minute warning. We just have used up time in the perfect amount of time. Are there any questions about that? Yes.
So many. But I'll start with code systems that aren't like known for FHIR. Example is NBC National Drug Codes. URL appears in an instance, running the basic Happy validator I'm getting here. I don't necessarily want to create value sets for that. I just want to sort of silently ignore, yeah, you're using NBC codes because you're a pharmacy use case. How do I, easy way to sort of turn that off?
So the easiest, so Rick's question was, what if I've got a code system that's not known to FHIR, let's say it's fictitious, let's say it's RxNorm. So I want to deal with RxNorm. I don't actually want to validate the codes. I just want to say, okay, if it's an RxNorm code, let's just accept it and move on. Is that roughly the question there?
Yeah.
Okay, cool. So the easiest way to do that is write your own validation support that basically returns null for almost everything, except for, there's one method in there, supports code system, if you declare that you support the code system, the canonical URI for RX norm, and then if you say true to that, then it's going to then try and call validate code for your code. You can return true there.
And we're always, okay, good.
Exactly, yeah.
Okay, perfect.
Anything else?
Yeah.
Do we have same thing in the document?
The same thing as the support code system? No, you will have to create a code system that doesn't contain any code, so it will find it. I was just, while you were asking, I was just writing down, hey, that's a good idea. Let's do that. Yeah.
Yep. Cool. So I guess we've got, oh no, one more question.
So if I have an implementation guide that I'm working on that has all new profiles, how do I get them into Happy's validator?
Oh man, there's...
That's the file system one that I was...
No, this is a great, actually I forgot all about that. I was going to mention that. I was thinking about it this morning. So there's one other implementation of iValidation support that is just about finished. I started working on it at the last Connectathon and then forgot about it until a couple of weeks ago and thought, oh yeah, I should finish that. And that will take IG zips as an input, and it understands the structure of IG zips. So the easiest way if you've written an implementation guide is to take that zip and feed it to the, I believe it's IG pack validation support module, which is not in the current release of Happy, but will definitely be in the next release.
Okay.
Cool. So we have got 10 minutes to go and get waffles. Everybody get some sugar in you because we're going to look at code after the break.
Ooh.